Welcome back to Interactive Schooling. In the previous video, we learnt about symbols. So if you haven't looked at that video yet, do go and have a look at it so that you get a continuity. In this video, we learn about the first 20 elements. They are actually very useful to know, the first 20 to 30 elements. It's best if you know them by heart. And about how atomic number plays a role in the chemical reaction, about the valency. And we'll try to complete as much as we can in this video about that topic. So, the first 20 elements are, these are the atomic numbers of the elements up to 20. So now we look at the electronic configuration. As we already learned, there are only a certain number of electrons that a shell can accommodate. That we can find using the 2n square formula. So if you take hydrogen, its atomic number is 1, which means it has only 1 electron. Now let's not talk about protons because that's not that much related to this video. So let's take hydrogen. It has a nucleus and it has 1 electron. So all it needs is 1 shell. That's all. This is the electronic configuration of hydrogen. Hydrogen's electronic configuration is 1. That's all. The next one is helium. Helium has atomic numbers 2. So its electronic configuration is 2, which is accommodated in the K shell itself. Now going on to lithium. Lithium's atomic number is 3, which means 2 electrons in the first shell. Where will the remaining 1 electron go? For that, there is another shell which has only 1 electron in it. So this is like a waste of space, right? So let me make one thing clear. This outermost shell is called the valence shell. And the number of electrons present in the valence shell is called the valence electrons. So the electronic configuration for lithium is 2, 1. Next, it will just go like 2, 2, 2, 3 like that. So now for neon. Neon has 2 shells here, but it has 10 electrons, right? So it needs 8 more. It needs space to accommodate 8 more electrons. So another shell. And the electrons have to be in pairs. Remember that. So if you are asked to draw the structure of an atom, you have to draw them in pairs like this. So 2, 8 is the configuration for neon. So now both the shells are fulfilled, meaning the number of electrons that they can accommodate is fulfilled. There is no waste of space. Next, if you go to sodium, its atomic number is 11, right? So 2 here, 8 here, and it needs space for 1 more electron. So here 1 more shell comes here, and actually it should not be directly in front, it should be diagonal like this. So this is a sodium atom. One more thing that you have to remember is, while you are drawing the structure, you have to mention the number of protons and neutrons. So number of protons is equal to the atomic number, so 11 protons, and the number of neutrons for sodium is 12. That is, unless you know the atomic mass, you won't be able to find the number of neutrons. So the number of neutrons is 12. So this is how I have written it. This is the nucleus means. Inside that I have written it like this. I think you won't be able to see because of the size. Like this. So this is the structure of sodium. Now coming to argon. Argon is also an inert gas. So it will have the electron. This will have electronic configuration 2, 8, 8. Coming to potassium. You write the number of protons and neutrons here. K shell has 2, L shell has 8, M shell has 8. But here is where the twist comes. Even though this L shell can accommodate 18 electrons, you are not supposed to add one more here. You are supposed to add another shell, and inside that you are supposed to add one more electron. So this is where most of them get confused. The exact reason we will see later in this video. There is something called the octet rule. So it's like that. So this is what I wanted to show in this video mainly. So while you go to the while you have completed filling the M shell with 8 electrons, you are not supposed to add one more. You are supposed to go to the next shell. It should accommodate only 8. So the reason for this is there is something called the octet rule. The exceptions are hydrogen and helium. We'll discuss that later. So there is something called the octet rule. What does octa mean? Octagon. Octa means 8. So octet rule means the valence shell of the atom. The valence shell is the outermost shell. Right, so this outermost shell should have 8 electrons. Only then it will have a stable structure. In the case of sodium and chlorine, okay, we'll take two things, sodium and chlorine. What happens is, in sodium, this is completely filled. This is also completely filled. But this one, it has 1. But it needs 8 electrons to fulfill this, the octet rule. So what will it do? It would rather donate its one excess electron outside. If it's too hard to gain 7 more electrons, right? Where will it go for 7 more electrons? So it will just donate that 1 electron. That is, it will lose its 1 electron. So its valency is +1. This plus is used to denote the charge on the ion. Ion is a charged particle which is formed due to loss or gain of electrons. So here what happens when it loses 1 electron? The sodium, there is no change in the number of protons. Sodium will have 11 protons and 12 neutrons. But upon losing, it will have only 10 electrons. So 10 electrons, that is 10 negative charge, but 11 positive charge. What happens? 11 positive charge. What will happen? You will get 1 excess positive charge. So this is not neutral anymore. It has 1 positive charge. That is what an ion is. An ion is a charged particle which is formed due to loss or gain of electrons. This does not necessarily have to be only positive. In the case of, let's say oxygen, oxygen's atomic number is 8. So it has 8 protons and 8 neutrons. 2 here. But it has only 6 in its outermost shell. It needs 2 more to fulfill its octet. So, one thing is why it can't lose these electrons. Why it can't lose it is one thing. To what will it donate 6 electrons? Right, that is one thing. The other thing is, here there are 8 protons. Okay, so there will be more attraction towards this shell, right? This will, lot of positive charge will be released, and so these electrons will be attracted towards this nucleus. So the nuclear force of attraction is very high, and hence it will not be able to let go of its electrons that easily. So it tends to gain 2 electrons. Okay, so let's say it has gained from magnesium. Magnesium, in the sense, in its K shell it has 2, in its L shell it has 8, in its M shell it has 2. So it tends to lose these 2 electrons and it will attain the form of Mg2 plus because it has 2 excess positive charge. So it will be in the form of Mg2 plus while oxygen gets this. It's in need of 2 electrons, right? So what it will do, it will gain 2 electrons. So what happens now? It has 8 protons but it has 10 electrons. So on subtracting, you get minus 2. So it will have charge of minus 2. So its valency is minus 2 and its ion is represented in the form of O2 minus. And of course, this is positive, this is negative. Both of this, since the charges are opposite, they tend to attract each other. And what happens? This minus and this plus, these 2 charged particles, they get attracted to each other and they form magnesium oxide. So this is how a chemical reaction takes place. And as I already said, hydrogen and helium are exceptions. They only need 2 electrons to fulfill their thing because the K shell has the capacity to only take in 2 electrons. So that's called the duplet rule. So for other than for hydrogen and for helium, all the other elements follow the octet rule. So that's all for today's video. I hope you understood this concept. This video is actually comparatively much longer when compared to the other videos. So but still I hope you understood the concept and I'll meet you in the next video with some more information about a chemical reaction. Until then, goodbye friends. Don't forget to like, share and subscribe to the channel. Bye.